The broadcast is now starting. All attendees are in listen-only mode.
All right, thanks everyone for joining. I'll go ahead and get started since we hit the top of the hour. Good morning, everyone, and welcome to the September California Nevada DEWS Drought and Climate Outlook Webinar. Thank you to those that have joined us previously and those who may be joining us for the first time. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NIDIS in California, Nevada, based out of Scripps Institution of Oceanography at UC San Diego. This bi-monthly webinar series is designed to provide California, Nevada with timely information on the current drought status, associated impacts, as well as a preview of developing climatic events. This webinar is being recorded, and it, along with a two-pager, will be available on drought.gov later this week, and the email will be sent to you if you registered and are attending. Before we get started, we just like to talk a little bit about so you know who we are and what our missions are. I am with NIDIS, the National Integrated Drought Information System. Our mission is to improve the nation's capacity to proactively manage drought-related risk. Basically, we want to improve our understanding of how and why droughts affect society, the economy, the environment, and make sure information is accessible and usable for early warning for drought risk management. To achieve this, we were prescribed by Congress to reach this goal, and we tried to hit this mission by regional drought early warning systems, building out towards a national drought early warning system, and activities related to prediction and forecasting, integrated research and monitoring, drought planning and preparedness, and collaboration with existing programs and partners, so some you'll hear from today, as well as the drought portal, drought.gov, which is where we sit. So what is a regional drought early warning system? Basically, we utilize new and existing partner networks to optimize the regional expertise around drought. So that way we have the right climate and drought science and impact data available, easily understandable, and usable for decision makers. And on the right here are just some of the types of bulk activities we've labeled are important for regional drought early warning systems, from monitoring to forecasting, research and communication, etc. Specific to the California Nevada drought early warning system, we do have several activities in priority areas along that bubble diagram you saw in the last figure. And part of my role is to help make sure the DEWS network is collaborative, talking to each other and having an open network of discussion, as well as talking about how we respond to drought and improve drought early warning communication and outreach. So that's just a little bit about us. I'd rather have you guys spend time with the great speakers that we have today. Here on the slide, you'll see the agenda for today. Typical of these webinars, first we'll have the Drought and Climate Update from Dan McEvoy from the Western Regional Climate Center, followed by the Drought and Climate Outlook from Michelle Mead from the Weather Service in Sacramento, followed by Mike Dettinger from the USGS talking about some of his drought early warning approaches and tools that he has developed. And with that, I'll introduce our first speaker. As I mentioned, Dan McEvoy. He's a climatologist with the Western Regional Climate Center at the Desert Research Institute in Reno, Nevada. You may have heard from him on these webinars before, and he's been a great partner for regional drought early warning activities, including the Evaporative Demand Index and other tools and things like that. So with that, Dan, I'll change presenters to you and we'll get started.
All right, thanks, Amanda. Let me get my screen set up here. All right. So I'm going to give a little update on kind of what we've been seeing in the recent past, last few months in the water year in terms of drought in the region. And thank you again, Amanda, for inviting me to give this update today. So I want to start out with a latest snapshot from the U.S. Drought Monitor that depicts the overall general drought conditions in the region. And most of our region in California, Nevada is filled in one of the colors there. A lot of the region in the north is in D0, which is abnormally dry, and also D1, moderate drought. There is more severe drought conditions depicted In the southern part of the region, particularly far southern California, there is some D3 extreme drought, and some severe drought has creeped into parts of northern California as well. This next map shows how much the drought monitor has changed over the last 3 months. We don't often see a ton of changes during the summer season, since it is the dry season in California and Nevada, but there still can be drought impacts and intensification during this season. And so what we're seeing here is that most of the region didn't see a lot of change over the summer, but particularly along the California Oregon border and the Nevada-Oregon border, there were some two-class changes, two-class degradations. And so, although it is the dry season, the droughts can intensify due to things like warmer temperatures. So we had a very warm summer, which I'll show, and also this was followed by a another poor snowpack year, another snow drought year. And so the combination of those things can intensify droughts during the summer, even though it is still our dry season. So I want to give a water year recap of the temperature and precipitation. These are maps from the Westwide Drought Tracker. On the left, we have the October through October through August precipitation percentiles, and on the right are the temperature percentiles, and this is based on PRISM, so they're ranked going back to 1895. So in terms of precipitation, there was a bit of a dipole where the southern part of the region was much drier. Most of the southern part of the region was in the bottom 10th percentile, whereas central and northern California and Nevada were kind of near normal, slightly above normal in some spots. However, northwest California stayed pretty dry. And temperature, this is kind of more of what we keep seeing, another very warm water year pretty much throughout the region. The southern part of the region saw record warm October through August temperatures, and so the combination of the warm temperatures and low precip in that region has really exacerbated the drought conditions. And more recently, so these are the same maps now, but just showing June, July, August. Of course, we don't typically expect much precipitation in a lot of California during the summer, but Northern California does get some precip normally in June. They didn't see much of that this year, and so their summer was some record dry locations. We did see some decent monsoon rains as you go further south, and so some parts of Southern California and Nevada were a bit above normal for precip. Temperatures, record warm summer for a lot of places in the Sierra Nevada, Central and Southern California. Central California was a bit above normal, and some parts of northern coastal California were actually a bit below normal. But overall, very hot summer for the region again. And I also wanted to show the summer evaporative demand drought index, and kind of show how it reflects a combination of different features of both temperature and precip. So it takes into account temperature, precipitation, wind, and solar radiation. And I really wanted to just make the point that you see in the southern part of the region, there's some blues showing up, so that's increased, or below normal evaporative demand. And so this isn't just reflecting the temperature in the Great Basin and in the Southwest. Wind speed is the dominant driver of evaporative demand during the summer. And so that's being reflected here. There was below normal wind speed spatially, and increased humidity and dew points due to the increased monsoon in the region. And so that's being reflected in the eddy. But meanwhile, Northern California and Central California were in the top 2 percentile. And so that led to increased drying of the fuels and led to kind of some more severe fire conditions. And we saw some pretty bad fires already this summer, and the fire danger is not going to decrease until we get really our first big rain event, whenever that might be. I did want to touch on the water supply. So we're kind of at the end of the water year, moving into the start of the next year, and it's good to take a look kind of where we stand in terms of regional water supply. So first I want to show the California reservoirs. This is from California DWR. And this is kind of a snapshot of a lot of the major reservoirs in the region. So overall, A lot of the reservoirs are near normal, some slightly above average, some below average. Overall, we're a bit lower than we were at this time last year. That makes sense because we had our record precipitation year the year before, and so all the reservoirs were basically completely full. On the right, I picked out a couple just to see where we stand compared to last year and some major drought years. So we have Shasta is on the top right, and then Folsom Lake is on the bottom right. And the dark blue line is this year. The kind of teal shading is the historical average, and then the light blue line is where we were in 2017, and then the red line is where we were in 2015. Of course, at the heart of our most recent severe drought. And so both Shasta and Folsom are a bit below average, not too far off. So overall, the reservoirs in California are still in decent shape, but it could get a lot worse if we don't have a decent or above average snowpack year this year. So we're really banking on that. In terms of the Nevada reservoirs, Lake Tahoe's one of the biggest reservoirs that supplies a lot of northwestern Nevada. This is going back, a time series going back to 2011, and Tahoe's basically still pretty full. Tahoe takes several years to respond to drought, 3 or 4 years before it gets kind of critically low. And so Tahoe's still really full. We did lose quite a bit of water this year, but that's kind of the normal cycle. And so even if we did have a drought year, Tahoe wouldn't get dangerously low. And so Northwest Nevada water supply is probably still in pretty decent shape right now. The reservoirs that we do need to start thinking about are the smaller reservoirs. And so this is Rye Patch Reservoir, which fills up from the Humboldt River Basin, which is a very large river basin in central and northeast Nevada. It supplies water to Lovelock, which is a major ag region in central Nevada. And so it's kind of hard to see, but I just highlighted this red circle is the latest observation. I think this was from late August. And this oval kind of shows how much the water has come down throughout this year. And so they've lost quite a bit of water. And unlike Tahoe, this reservoir can fill up and empty out in 1 or 2 years of drought. And so we're really hoping for a better snowpack in the region this year to refill this reservoir. Otherwise, it could start getting low next summer, and there could be some water issues for ag in the region. The latest stream flows, and so this is the 7-day average stream flow, and the colors are only showing the stream flow gauges that are in a drought classification. And so there's quite a few gauges in California in the 6th to 9th percentile, which is that orange color, and then less than the 5th percentiles in the darker red color. And so this kind of makes sense when you're looking at the U.S. Drought Monitor map, why we are in drought in this region. Stream flows are pretty low in a lot of places right now. Same thing with Nevada. Across central and eastern Nevada, there's quite a few gauges that are in less than 5th percentile. We're not as bad off as Utah, where a lot of those gauges are near record low. But again, due to the poor snowpack, early runoff, warm temperatures, the stream flows are not in great shape in a lot of places right now. And I wanted to touch on the current ENSO conditions. I think our next presenter is going to talk more about the outlook and what we can expect going into fall and winter. So this is the latest sea surface temperature anomalies from the week of September 9th through the 15th. And the ENSO region is the central and eastern equatorial Pacific here, and there isn't a huge signal showing up right now. We're currently in ENSO neutral conditions, so we're not in an El Nino or a La Niña. There are a few things to note. So to the north of the ENSO region, there's a very kind of long plume of above normal sea surface temperature anomalies that stretches from Baja California all the way out towards the date line, and there's some very warm water out there. I don't want to speculate on what that's going to mean for our fall or winter yet. I think it's worth keeping an eye on, though, because it is a pretty distinct pattern in a region that can potentially impact our winter weather. So we'll keep an eye on that. But in terms of the ENSO conditions, this is a slide I took from CPC's weekly discussion, which was updated just this morning. And so the map down here shows the different Niño regions. We often see forecasts of this Niño 3.4 region, which is right here. And so 4, 3.4, and 3 are all above average and have been warming. And so on the right, it shows how they've been changing since last October, and we've seen quite a decent warm up in 4, 3.4, and 3. But it's the region furthest to the east that is actually still below average. And so this is really important. It does matter the exact location. If we do transition to an El Nino, it does matter the exact location and how that's going to impact our weather. If we have a stronger, warmer ENSO in the eastern region of the Niño, that has led to these stronger winters in the west coast of California and into Nevada. But it's a lot more uncertain when the waters in the eastern Pacific stay cool and the kind of El Nino is shifted towards the 3.4 and 4 region. So not all El Niños are the same, and we need to keep an eye on exactly where the El Nino sets up this year if it does develop. And I just want to take a couple of minutes to kind of plug a new product at the Climate Center, the California, well, not a new product, an updated product, the California Climate Tracker. We've been thankful for getting some support from the California Department of Resources to upgrade this product that was developed about 10 years ago, and it was kind of in some need of an upgrade, kind of in look and feel. So this is a screenshot of the new dashboard. This does run on Prism data, and so you can view precipitation, maximum temperature, and minimum temperature from the entire Prism record. We have different polygon regions. This is showing the California climate regions, and then we also have the DWR hydrologic regions that you can view. So on our dashboard, we have an interactive setup where you can hover over these different regions and get the most recent conditions. And then on the left, we have a product filter where you can look at time series and maps going all the way back to 1895 for whatever kind of time period you're interested in, whether it be water year, summer, winter. And I did want to give some thanks to our new software developer, Justin Chambers, who did a great job. And he's kind of developed kind of a new framework that we're working on at the Climate Center for all our new websites to kind of have a look and feel that may end up being similar to this web page. Like I said, you can, one of the new features is now you can look at the archive maps going all the way back to 1895. So you used to only be able to look at the most recent maps. So this is just an example showing the winter, December through February, precipitation percentile rankings. This was for last year, 17-18. The Sierra Nevada was in the 3rd percentile, and so things were very dry until we got bailed out slightly in March. But before March, we were looking at one of the driest winters on record. Compare that to the year before, 16-17, where we saw our wettest winter on record. And so now you can compare all these different time periods and different drought years and wet years that you're interested in. And we still have the time series tool. So this is just an example of summer minimum temperature for the South Coast climate region. We have the anomalies, and we have our summary statistics showing the mean, the median, the warmest, the coldest. This year did happen to be the warmest on record. And so you can do this for minimum, maximum, and mean temperatures. And the last kind of a new feature we have on our dashboard is an interactive heat map, which you can pick whatever variable you want for whatever region. And so this is mean temperature for the Sierra Nevada region. And it shows all the temperatures for every month back to 1895. And so you can get a sense of different trends. And you can do this for precipitation as well to pick out drought periods, and you can hover over these on the dashboard and get the actual values and the anomalies. And so this was another new feature we added. I did want to also note that we are working on these trackers for all the states now, not just California, so Nevada should have one soon. Basically the template set up for California, so it should be an easy transfer to other states to get these similar products. And so we will update you all on when those are ready to go. And that was all I had. So I don't know if there are any questions, if we have time for that now, but thank you.
Great, thanks, Dan. As of right now, I don't see any questions, but I forgot to say at the beginning that for most of the attendees that we do tend to save questions for the end. So we don't have a question now or a question comes up later, feel free to type it in and we'll address them later on. But otherwise, thanks, Dan, and we'll switch to the next speaker. So our next speaker is Michelle Mead. She's the warning coordination meteorologist with the Weather Service office in Sacramento. And Michelle, I'll pass control over to you now.
Thanks. There we go. Everyone see my first slide there?
Yep, you're good to go.
All right. Good morning, everybody. My name is Michelle Mead. I am the warning coordination meteorologist with the National Weather Service in Sacramento. I'm going to be giving a talk that I believe is becoming near and dear to my heart. It's probably one of the main topics that we get asked to speak about. Thank you, Dan, for setting me up nicely, because it did talk a little bit about the variants in California. If you've lived here your whole life, you're very familiar with our water story. California is one of the reasons people love to live here is because we are a Mediterranean climate. And what that really means is we have 6 months of wet weather traded off by 6 months of sunny and dry weather, which is perfect for the outdoor enthusiasts, the beachgoers, and all the folks who love to come to California. But our water year is really the 6 month period from October 1st through May. And our prime months for our maximum precip in those 6 months is December, January, and February. So we always preach, we, the Weather Service and the Department of Water Resources, get out every late summer and fall and start talking about the winter outlook. And you've already heard Dan mention that ENSO phase El Nino is in the works for this upcoming winter season. And everyone gets excited because they associate El Nino with a lot of rain in California. And like Dan has already mentioned, and I'm going to show later on in our presentation here, that that's not always the case. So in winter season, we always like to preach that California should always prepare for flooding during the winter season. It doesn't matter what ENSO phase we're in, whether it be El Nino, La Niña, or neutral. During our winter season, this is where our water supply gets replenished, and that's due to the storms that come in off the Pacific. And the greatest storms that really replenish us is the atmospheric rivers. And the bottom image here in the lower left is an example of what an atmospheric river is. It's also been known to be called the Pineapple Express. They are one and the same. Basically what it means is you've got this plume of moisture that starts from the tropics and feeds all the way into California. Now, not all atmospheric rivers are the same. They can be on the weak variety or the very strong variety. On average, California sees 5 to 7 atmospheric rivers a year. And this is kind of a no-brainer, but when we get less atmospheric rivers in our winter season, we tend to see drought conditions either develop or continue. And when we get more, like we saw in 2016, 2017, which was a neutral year, by the way, we will potentially see flooding and drought improvement. And I just want to emphasize here again, El Nino does not guarantee an increase in atmospheric river storms or a wet winter. So without further ado, we're going to go ahead and take a look at your outlook. We're going to start with the latest ENSO predictions from the Climate Prediction Center. So this was just issued last week. We are still in an El Nino watch that was issued in June of this year. And the latest statistics are showing that there is a greater than 50% chance of El Nino during the Northern Hemisphere fall, which, as you know, we just entered this weekend. It was the fall equinox. And then it's increasing to 65 to 70% during our winter months, which is the December, January, February. And again, El Nino does not guarantee a lot of rain in California. This is an image of what a strong El Nino looks like. This was a satellite image actually taken, the strong El Nino of 2015, 2016. And you can see the warm waters off of South America all the way back to the central portion of the Pacific. And this is the latest long-range models of El Nino strength. So just for your reference, anything between a half a degree and 1 degree above the normal is considered a weak El Nino. So these are all of the ensembles that they're taking a look at, and this green line is the one that the statistical average that they base their forecast off. So you can see it's peaking right under 1 degree in the December, January, February, peak of our winter, and then slowly goes back to negative 0.5 or neutral conditions as we enter the spring months. This is what a typical El Nino winter storm track looks like. Basically, the jet stream is prevailing across the southern United States and South America, and that's why you typically see Southern California and the Southern Great Basin favored for potentially wet conditions. And then warmer and drier conditions are typically in the Pacific Northwest. What I want to note here is most of California and Nevada are in this we have no idea area. I've always kind of joked that California and Nevada are the redheaded stepchildren of the rest of the United States, because a lot of the statistics that scientists like to use don't really apply to California and Nevada, because we kind of make up our own rules with water and with weather. So we had a colleague in our office take a look at all the past El Nino events. This is weak, moderate, and strong. You can see we've had 23 in the last, since we were able to keep records in 1968 until 2018, and we've had 23 of them. And you can see it's all over the board. The strongest signal has been historically in Southern California for a wet signal, but not always, because the strong 2015, 2016 El Nino, Southern California actually had a below average winter and we had an above average. So keep this in mind as we look through the seasonal outlooks that come from CPC. You're going to see a strong tendency to the Southern California signal with a lot of no color over Central and Northern California, which basically means equal chances of all three of these outcomes: wet conditions, normal conditions, or dry conditions. So without further ado, here is what the latest and greatest from the Climate Prediction Center. We're starting with this current month, September, October, November. The precipitation that you see here in the Southern Great Basin in California, Nevada, that's still a signal of the monsoon season, which is coming to an end here very shortly, but that has nothing to do with the El Nino forecast. The temperatures should be no surprise to anybody. This has basically been the trend for the last several years, where temperatures are trending to be at or above average, and that has definitely been the case. And with the El Nino outlook, it's also something that we're expecting to continue into this fall. As we move forward to October, November, December, as we start, this is when we kick off our water year, you're starting to see the monsoon signal evaporate, but the El Nino signal is starting to come to fruition. You can see the drier conditions in the Pacific Northwest for that dry warm, with the precipitation, again, favoring Southern California, but again, that's heavily weighted to the El Nino outlook. That continues for November, December, January. Above average temperatures probability is greatest during this time frame, with precipitation for the Southern California, and again for our wet months of December, January, February. Now, like I mentioned, you don't want to put a whole lot of weight on these, because this is only a 33% chance of above average, but there's still potential for at or even below average precipitation. Southern California has actually been left out of all of the bumper crop precipitation years that we've had. And even this year's monsoon was lackluster, is not what they were hoping for. So as far as drought conditions go, these areas in southern Nevada and southern California are still the heaviest hit, and we'll have to keep an eye on those. But if we are able to get our normal precipitation up here in our central and northern California, and keep in mind that's where a majority of the big workhorses are for reservoirs that do supply the water supply to California, as long as we can keep those guys healthy and at historical averages, will be good for our water supply. So just to recap, water season is the flood season for California and Nevada because we are dry in the summer. You can have flooding conditions during drought conditions. All it takes is a lot of precipitation in a short amount of time, and you can have a quick little flash flood. A weak El Nino is forecasted for this fall and winter season, but again, it does not guarantee a wet winter. The reservoirs that Dan showed are lower than September of 2017, but still near historical average. And the exception there is Oroville. That is because of the all of the modified operations for the spillway that is being under construction. And it's just another reminder that any large storm runoff could cause moderate flood control releases. So since our reservoirs are near historical averages, when we get to that historical average and get into the height of our wet season, we do have to keep flood control space. So not only could we see a high atmospheric river, but there could also be releases contributing to the rivers down below. And that's it for me. I'll pass it back to you.
Great. Thanks, Michelle. We have one quick question we can get now while I'm changing slides over to the next speaker, and that is, do you have a sense of how much the West Coast warmth in these outlooks is trend versus ENSO?
Most of it's trends. Like I said, as scientists really like our numbers. And when the ENSO, the El Nino signal or La Niña signal, there's many signals that go on in the Pacific that can actually influence the weather. We just have the strongest research and numbers for the ENSO circulation. So we do tend to put not all of our eggs in one basket, but a majority of them. So it's more of a trend forecast. And I think just even the last 5 years is a perfect example of why the West Coast, especially California and Nevada, we don't fit into those trends nicely.
Okay.
Did that answer your question?
Yes, thank you.
You bet.
And then our final speaker is Mike Dettinger. He's with the USGS. He's a senior research hydrologist, and he's also heavily involved here with the CNAP, the NOAA RESA program. And so this time in the webinar, we usually cover tools or new innovative research and things like that. And Mike is who I consider one of the greats of the tool development. So I'm going to let him have a chance to talk about what he's worked on along the way. And Mike, I'll switch over control to you now.
Oops, okay. So can you see my screen?
Yes.
So hi, this is Mike. Yeah, I just wanted to show you a couple of new ways that I've been using to look at droughts, basically pulling together, frankly, kind of different aspects of drought with an eye towards looking at how things are changing, where these aspects of drought come together. That may become a little bit clearer as I go along, but anyway, I'm going to just show you two new data displays essentially that you might want to consider. They're both now sort of available online, or at least during the winter season. During the wet season they will be. And let me see. Really, I do look at droughts for lots of reasons, just as we all do, but just to sort of motivate this a little bit more, why I'm looking at non-traditional ways of pulling the data together. I just, here's some things that we think we know about future climate and future droughts. You can see the list here. It's going to be warmer, more dry days per drought, but our droughts will tend to be interrupted by larger, stronger storms, less snow, more rain, and evaporative demand's increasing. And with all this going on, I think that we need to make sure, we need to be thinking about the drought indices that we use. You know, are we going to be picking up on these kind of changes as we go forward, or are we going to be tending just to sort of watch the indices and not notice that some aspects are changing? Today, I just wanted to show you some things that pop out of just a couple of these kinds of changes. The business of, you know, with stronger storms when they arrive and more droughty conditions, it becomes really important to know how much a big storm is actually doing to the drought. And so, you know, paying more attention to the impact of storms within droughts. And then the other is basically, if we're going towards more rain and stuff, how are we to really keep track of where we are in terms of storage overall, water storage overall. So anyway, on the first of these, basically the map here shows what I would consider sort of a traditional way of looking at the onset, if you will, of drought conditions. This was a map that was made on February 1st of this year, and it shows the percentage of normal water year to date precipitation that has fallen all over the place. And the orange and red colors are where there's very little precipitation has already fallen by February 1st. And up in the Northwest, you see areas where well over 100% of normal for that day of year had already fallen. And just to call attention to it, the little writing down here at the bottom where it says, you know, most of the Southwest fell between 30 and 90% of normal, and as mapped this way, and most of the Northwest fell between 100 and 160%. And I put that up there just for comparison to what I'm going to show you next, which I think gives a slightly more black and white picture as to whether we're sinking into drought or not. And you know, so this is a fairly broad range. 30 to 90%, you know, covers from anywhere, you know, a pretty broad range of outcomes. And anyway, I just think that I'd like to suggest a way that might help us to know a little bit earlier on how we're sinking into drought. And what I do, not really rocket science, although this might look kind of complicated, but basically I take that business of where we stand in terms of the precipitation that's fallen to date in the year, and I just add to it information about what has happened historically in the last 70 to 120 years, depending on how I do this. But what has been the distribution of precipitation totals for the rest of the water year? So if that's February 1st, percent of normal precipitation, then this over here is what's the distribution of February through September precipitation totals historically. And in doing that, what I get to is this business of what are the odds of reaching a normal 100% of normal water year precipitation total by the end of the water year. And for that same period, based on what we knew by February 1st of 2018, here's a map for the West of the odds of reaching 100% of water year normal by the end of the water year. And the colors here, the whites into pinks and reds, are where there's very little chance of getting to normal by the end of the water year. Up into the blues and the like, where it's pretty much a done deal that you're going to be you're going to have reached at least 100% of normal by end of water year. And when it's mapped out this way down here, you see this business of most of the Southwest fell in terms of these odds of reaching normal between 0%, this white stuff, for instance, here, sitting over here by the Apache lands, between 0% and 30% of odds of reaching normal. The Northwest was sitting between about 85% and 100%. And so in that sense, these are narrower bands of probabilities or anomalies than we were looking at with the more traditional way of doing this. Now, I'll say that this URL that's sitting at the bottom and has been sitting at the bottom all this time is where you can go to see this new tool that we put up online, and that will automatically update each month from now on, as far as I know. So, you know, write down that URL down there. But if you've already done that, then I'll say, you know, here's a figure that shows starting down here in this corner and working its way up and through it. Here's how these maps of odds of reaching normal have played out over the last year. And basically, I'll call your attention to by say January 1st, over here in the Four Corners region, we're way down there near, you know, mostly below about 20% odds of getting to normal. So as early as January 1st, I was saying, you know, they're in trouble there. By February 1st, a lot of California was in that situation, and because January was a dry year, a dry month in the Southwest, you know, the Four Corners region had fallen even further into the hole. You may recall that March and April were miracle months that sort of, you know, we got a lot of precipitation and thought, aha, we're saved. And so if you compare, for instance, the distinction here between the March 1 map and the April 1 map, well, you can see where that extra wetness that we got in those months kind of bailed us out. If you include up here into May 1st, an awful lot of this area had sunk into the onset of drought quite early, I think, and just historically, unless a really truly record-breaking event that stood out from everything else that historically happened, we were not going to get out of this drought. I'll note here on April 1st, just one thing to note is that, hold on here one second. Well, actually, I've already sort of said it, is that the March miracle mostly benefited some places in northern Nevada and over here over by sort of Susanville and the like, but most of California continued its slide into drought. And I will also say, yeah, that was the point I was going to make, is I know that most of us on this call aren't that interested in the Four Corners region directly, but, you know, for them, it's a matter of, you know, okay, it's April 1st. Oh, you know, hope that the monsoon will come and bail us out. But historically, they were so far in the hole, this was showing that there was just no chance they were going to be able to dig themselves out, again, without some truly mammoth, you know, totally out of the ordinary and totally beyond the realm of what had happened historically, monsoon. They were already stuck. So, so that's how these things evolve. I think it gives you a slightly earlier look at what happened, at what's going on out there. And this is a lot of different maps here, but basically, if you go to this URL down here, we're putting up these maps for various different options. This is the one we started with, the sort of traditional way that you can get a look at there. We've been looking a lot at this odds of reaching 100% of normal. That will be there, as well as that whole historical thing that I just showed you as to how the year to date has gone. So you can see the trends that have been developing. It's at this site, we don't just show you the 100%. There's 50, 75, 100, 125, and so on. A whole bunch of different options for what the odds are, and it's done the same way, but it's for reaching different thresholds of precipitation. Down in this corner, we also, well, I think I'll let you figure out what this one is, but basically it's turning the question around and saying, if you want to know what the 50%, what the precipitation amount that you're likely to, that you've got a 50% chance of exceeding this year is, this maps it out in terms of the local normal precipitation. You'll have to look at it to see what that is. That's a little bit hard to explain on the fly. But I will note also this one here in this corner, the odds of reaching 100% of normal for the sum of water years 18 and 19. We've added this because our friends at the Metropolitan Water District said that this was something that they felt that they were going to be needing soon under new drought regulations, or at least some proposed ones. And I mostly call your attention to it because if there's some version of this, some other questions you want to ask, let us know. We will if there's a way we can make it happen, it will. So I'm going on long, but here's the other bit, and this is much simpler. That's just, I believe that we should be tracking and looking at our storage in, say, the Sierra Nevada in terms of the snowpack plus the reservoir storage. Snowpack is measured and reported by one part of DWR. The reservoir storage is tracked and reported by another. We need to bring the two together, and that's all that's going on here. In these curves, and again, there's a URL down here that will tell you how to get to these things and see them as they develop this winter in real time. But the blue business here is the normal 30-year normal reservoir storage for the whole of the Sierra Nevada based on some 28 real-time reporting reservoirs. The gray is stacking the normal Sierra Nevada snowpack on top of that, so that the sum of reservoir plus snowpack is up here at the top of this dashed line. And those are the normals. And then as on a more or less day-by-day basis, we've got the how it has evolved through the year, with this orange one being the sum of the two and the red one being just the reservoirs. And you can see all these different years, some wet years. You can slide into the drought and see how bad it got. We were, the sum of snow plus reservoir wasn't even touching the normal amount that would have been in the reservoirs at that time of year. And whereas a really wet year like 2017 is shown here, and we got well above it. Now, why might we want to look at this? I may be pushing it here, but here's 2016. I just showed you that it was one of the ones on the slide before. And if you look at that sum of snow plus reservoir, you can see in that year we were looking at this, and you could just see that we were approaching the normal of the sum of the two, the normal total amount of storage up there in the Sierra by about February 1st. And whereas the reservoirs were just barely starting to feel it and just barely getting along. And the reservoirs didn't actually get to where this number was telling us they should get until as late as, say, May 1st. And so this is just a way of taking the data that we all have on hand, bringing it together to try and get a view forward a little bit. And in this case, arguably, it bought a few months worth of lead time. Now, you may have been aware of this. This is just putting it out there in front of you, so you don't have to do the numbers yourself. We're doing the numbers for you. And all we're doing this year, not all, but is splitting things out. Everything I've shown you so far is like this. It's for the whole Western Sierra. Here we've split it out into subsets of the Sierra, northern, southern, central, and southern, and they have very different mixes historically of reservoir plus snowpack, or of snow versus reservoir. Down south there's not much reservoir, but there's a lot of snow. Up north there's less snow, but there's a lot of reservoir storage, Oroville and Shasta and the like. And so we're splitting it out that way. I did this on the side and shared it with colleagues this past winter. And I think it was a useful way to keep track of how that was splitting out. And besides getting this stuff up online and automated, so it's right up to date all the time, the other thing that I'm doing with Nidus this coming year, is starting to do this for other places around the West. Some of these are well beyond California, Nevada, But again, folks like Metropolitan Water District have asked me to pay more attention to the Colorado, since it's a big player in our lives. So anyway, here are the two the two URLs that have been floating around this thing. These are where you can go to see these things, and they will be developing through time as the winter goes, as the water year develops. And I'll say that if you're interested in that odds of normal precipitation, but you want to do it some other way, or you want to do it just for your favorite weather station instead of on these big west-wide maps, the folks, our friends Nina Oakley and others at the Western Regional Climate Center put up this so-called climatic outcomes likelihood tool that allows you to go in and really it'll do the calculation for you. You can tell when you want to start it, when you want to stop it. Maybe you don't want to know a water year total, you just want to know a winter and spring total, or I don't know what, et cetera, et cetera. But here's a place where you can actually play with these tools, these numbers, in a pretty friendly environment. So that, I'm sure I went long, I always do, but that's what I had to share with you today.
Great, thanks, Mike. I'll say that in the post-webinar emails, I'll make sure to include the links for these so that folks can have easy access if they didn't get a chance to grab them here. Okay, I don't see any questions yet, but I want to give folks a little bit of time as we are here at the end for any of the speakers, including Mike, if you have some questions. While folks are doing that, first I just want to say thank you to all our speakers today. We couldn't have these webinars without the great partners in the region, like CNAP, the NORISA, USGS, Western Regional Climate Center, Weather Service, and others. And just a reminder that this webinar recording in the two-pager will be on drought.gov later this week, and I'll have a email sent to you all later as well with some of the links that came from today. And it looks like I might have a question. Okay, folks were asking Mike for your email and phone. Someone just popped that up. If whoever asked that question, if you email me, I can put you in contact with Mike, or if you want to rattle off your email, go ahead.
My email is mddetton@usgs.gov.
Thanks. Well, I don't see any other questions, and folks are starting to drop off. So I will end there and close the webinar and say thank you everyone for listening today, and thank you to all of the presenters.
Thank you.
Thank you.
Thanks.